In this pencast, we're going to be finding specified terms of arithmetic and geometric sequences. The first problem says, find the 10th term of the sequence 2, 5, 8, 11. Alright, so the first step is to identify what kind of sequence this is. So an arithmetic sequence, we know, is when the difference between terms is an additive constant. A geometric sequence is when the difference between terms is a multiplicative constant. Alright, so our first goal is to figure out whether this sequence is arithmetic or geometric. So to check to see if it's arithmetic, what we want to do is take the difference between each of the two consecutive terms. So 5 minus 2 is equal to 3. So now we need to check if the next terms have the same difference. 8 minus 5 is also equal to 3. So that's good. We're doing good so far. And then we have 11 minus 8, which is also equal to 3. So that's good. So we know that we have an arithmetic sequence here. So now what we need to do is find the 10th term. So let's go ahead and list our terms we have. So the first term is 2, the second term is 5, the third term is 8, the fourth term is 11, 5, 6, 7, 8, 9, 10. So this is the term that we're looking for, the 10th term. So, since we found out that this is arithmetic, we also know that the difference between all the terms is 3. So to get from one term to the next term, what we do is add 3. Okay? And that works for every set of terms. We always add 3. So to get the 10th term, all we need to do is continue adding 3 to each of these terms. So 11 plus 3 is 14. So the next term is 14. So then we add 3 to 14 to get the next term, which is 17. We continue the pattern. We add 3 and get 20. Add 3 and get 23. Add 3 and get 26. And then add 3 one more time to get 29. So we know now that our 10th term is 29 in this series. Alright, so the second problem says, find the 6th term of the sequence 3/4, 3/2, 3, 6. Alright, so we're going to go through the same steps. First we're going to check to see if this is an arithmetic sequence. Alright, so what we're going to do is subtract, so 3/2 minus 3/4. So that gives us 6/4 minus 3/4, since we need a common denominator, which is equal to 3/4. Alright, so now we're going to check the next one. 3 minus 3/2. That's equal to 6/2 minus 3/2, which is equal to 3/2. So 3/4 is obviously not equal to 3/2, so we do not have an arithmetic sequence. So now we need to check for geometric sequence. So to do a check for geometric sequence, since we know that every term differs from the last one by a multiplicative constant, we need to do division. So we're going to have 3/2 divided by 3/4. That's the same as 3/2 times 4/3. We know that because dividing by a fraction is the same as multiplying by its reciprocal. And when we do that, we end up with 4 over 2, or 2. Alright, so now we're going to divide the next one. 3 divided by 3/2. which is the same as 3 times 2 over 3, which is also equal to 2. So we're doing good so far. The next one would be 6 divided by 3, which we know is equal to 2. Alright, so check that off. We know we have a geometric sequence. Okay, so now we need to figure out how to find the 6th term. So again, let's write down the terms we have so far. So 3/4 is our first term. Our second term is 3/2. Our third term is 3. Our fourth term is 6. Then we have our 5th term and our 6th term. So this is what we're looking for, that term right there. So now, since we figured out it was a geometric sequence and that the multiplicative constant was 2, we know that to get from the first term to the second term, all we need to do is multiply by 2. Same thing again to get from the second term to the third term, and same thing again to get from the third term to the fourth term. So to get from the fourth to the fifth term, all we need to do is multiply by 2 again. So we're going to do 6 times 2, which gives us 12. And then to get to the 6th term, we just need to multiply by 2 again. So 12 times 2 is 24. So now we know that the 6th term of this series is equal to 24.